All right, page 502. Try to relieve your stress and your anxiety with some math here. And one anxiety transfer another. Anyway, it's less emotional, right? Math isn't as emotional, is it?
Yes,
it is? It's more emotional. Okay, then the book we're reading? Anyway, we were discussing her book. Anyway, we've been talking about the likelihood that a certain event will take place, or the likelihood of multiple events perhaps taking place. Class, the likelihood of events taking place is called probability. The likelihood of an event occurring based on past history is called relative frequency. How do I find basic probability, Michael?
Desired outcomes over possible outcomes.
Desired outcomes over possible. How about relative frequency, Brandon?
Successful outcomes over total outcomes.
Good. Successful in the past over total in the past. What do we call the likelihood that something does not occur, class? The complement of that event occurring. How do I find the complement?
Subtract from 1.
Just subtract from 1. We talked about a couple different compound probabilities. In one type of compound probability, we're making a single selection, but we would desire this or this. Anytime we have a compound probability of a single selection joined by the word or, what mathematical operation do we need, Audrey? We add. If we see or, we add. Addition is the mathematical. Okay, so we see or, we add. Now with the or, I say we add, and we do, but there's a chance that the two possibilities have, shall we say, a little bit of overlap between them, so that this and this maybe share a little bit. We would say in that case that the two events are not, class, mutually exclusive, if there's some overlap between them. And so how do we handle overlap, Kendall? Subtract that part away. So we would add the ors, but if they're not mutually exclusive, subtract the overlap. If this and this are totally separate, there's no overlap whatsoever, class, we would say that they are. And we have it easy. We just add them and we're good. However, we talked yesterday, and we didn't actually practice this yet, but this is going to be the focus of today's lesson. If we're making multiple selections, we want the probability that this happens, and then this also happens, and maybe this happens, and this happens. Well, every time we have an and, what mathematical operation do we need, Maddie? Multiplication. That's going to lower the chances every time you multiply. Now, with those, we said it is possible that this first thing happening in no way affects the other. If that's true, we would say that these two events, class, are, the first has no impact on the second. Independent. They are independent. If this event occurring, a first event occurring, has no effect on a second event occurring, we would say they're independent events. However, if this first event taking place changes the likelihood of the second event, then we would say those two events, class, are dependent, and we have to be able to account for changes in numbers that may take place. So here's the big difference, okay? And Abby, you said mutually exclusive a minute ago, and that's a common mix-up. Which one's which? Mutually exclusive, class, has to do with a single selection, whether or not there's overlap between those two selections. But it's still, or between those two possibilities we're considering, but it's still just one selection. Independent dependent refers to at least two separate selections, two separate probabilities where there's impact or no impact on the other. Does that make sense? So one's overlap between two possibilities, but we're only still going to have one outcome. The other is, we actually want two separate outcomes. Do they affect each other or not? Does that make sense? Mutually exclusive versus dependent. Clear as mud. All right, page 502. In your textbooks, you did pages 502 to 503, number 16, 18, 20, 28, and 30. Number 16, is that a valid set of probabilities? Audrey? Because they add up to exactly 1, and that's one of the key rules we have to look at. But there is a second rule that we have to follow. Probabilities have to be between what two values, Audrey? They have to be between 0 and 1, and so yeah, we're going to change that answer because of the negative. You can't have negative probability. So the probability that Abby gets through her book without strangling somebody who happens to be innocently passing by, Well, the worst, it would be 0% chance she gets through it. Negative chance technically isn't possible. Number 18, valid or not valid, Abby?
Yes.
Yes, valid. They're all between 0 and 1, and they add up to exactly 1. How about number 20, Maddie? Yes, they're all between 0 and 1. They add up to exactly 1. Questions on 16, 18, 20. Coming down, or coming across the page rather, number 28. They only wanted to know mutually exclusive or not. And again, you're making one selection. It's joined by an or, okay? And there's 2 bedrooms, guest room with a bed, kitchen, living room. They all need to be painted. What are the odds that a person comes in and paints either a room with a bed or paints the guest room? Would those be mutually exclusive or not, class? Not, because the guest room has a bed. So basically there's 3 rooms that could be painted out of 5. Still 3 to 5. Painting a bedroom or the living room. Would those be mutually exclusive or not, class? Yeah, that which is a bedroom is not a living room. Though you do live in your bedroom at times, it is not the same thing. Painting a bedroom or the guest bedroom, or the guest room rather. Those are still mutually exclusive because they specify a difference. It's not necessarily a bedroom, it's a guest room. Now what they did different, I don't know. But bedroom maybe for people of the house, guest room. Any of you have a guest room in your house? Nobody lives there except guests? How many of you, your room is the guest room, and when a guest comes, you get kicked out? That was me. Okay, Maddie, you suffering with me here. Okay. I expected Brandon's hand to go up. I'm surprised they kick you out. They never kicked my sisters out. It was always, of course, the sisters were sharing a room. I had my own room, so I guess it was easier to kick me out. But anyway, my dad liked my sisters better, so he always kicked me out, and I ended up on, like, you know, the couch bed. Or do you have a couch bed? What do you end up on if somebody takes over your room? Okay, so you go with mama. Okay, so yeah, your couch. There was one time I remember they put me on a sleeping bag on the floor, and they put a towel or something in the way, or a bed sheet or something to kind of section off my sleeping space because they didn't want to go to bed yet. So I'm in the living room, they're with the guests, they don't want to go to bed yet, so they're having fun out there, and I'm stuck on the sleeping bag behind a sheet. So anyway, all the memories. My parents made it very clear. It was healthy, it was healthy to learn. It's not about me. The family operates, I'm just a small part of the family. I'm not the central focus. That's healthy, I think, for a kid to know. Anyway, number 30. Tyler is planning weekend vacations in spring during March, in the summer during June, July, and August, and again in the fall during October. How many would like to have Tyler's money? All right, planning lots of vacations. What are the odds that he is either planning March or June or July? Would that be mutually exclusive or not? Yeah, because those 3 months are not the same thing. What are the odds he's planning either fall or August? Yeah, mutually exclusive, because August is not part of fall, especially not down here. In fact, down here we would say September isn't part of fall. In fact, even here, October doesn't usually feel like fall. He's planning a trip in the summer or in July. Not mutually exclusive. July is part of the summer. Questions on those? All right, so let's get some other work then. Page 511 from the homework. Page 511. Little bit of review here. We do have an exam coming up just a few weeks away now. And so good review here at the bottom of page 511, numbers 5 and 6, finding the designated terms in the sequence. And what do we call this rule in number 5 that the terms in the sequence are going to follow, class? The algorithm. So this is our algorithm. And they want the first 5 terms of the sequence. Remember, we could call the first term a sub 1, which means that n equals 1. So I plug in a 1 in class, I get 1. And then for a sub 2, I get? And a sub 3, I get? And then? And how many have these 5 terms on number 5? Questions on that? 11 over there. And then with the 4th, and just the 4th and 10th terms of the sequence defined by this algorithm. So I only want a sub 4 and a sub 10. Well, that's okay, because for a sub 4, Michael, all I do is
multiply.
I'll plug in the 4. And then, of course, multiply and subtract, and we get?
Negative 16.
And for a sub 10, all I do in class is plug in the, and I get, Audrey, negative who? Negative 46. Is that what you said a minute ago? It's what you said now. Negative 46. How many have negative 16 and negative 46 as the 4th and 10th terms? Questions? All right, turn the page. An arithmetic sequence. What is the formula for an arithmetic sequence? How many had to go back and look it up because you'd forgotten? That's probably human, right? What is that formula, Brandon?
A sub n equals a sub 1 plus n plus 1 times d.
N minus 1 times the common difference. And so they tell me that we want the 10th term, so we're finding a sub 10. They tell us that the first term is a 3, so I put that for the a sub 1. Obviously the 10 is the n, so we have a 10 minus 1 class, or, and usually I would do that step in my head, and then the common difference is 5. And so what is the 10th term of that arithmetic sequence, Brandon? 48 is correct. How many had 48 as the answer? All right, questions on that?
I had 47.
47.
Just
Any idea what you did?
probably just messed up a number.
Okay. Then for the next one, I want the 7th term. First term's 8, common difference is 6. Tell me how to plug in the numbers here, Abby.
So a sub 7 equals 8 plus 6 times 6.
There we go. Common difference is 6, and then the 7 minus 1 also gives me a 6. And so for our answer, we have
42.
class 44. 36 times 6, 36 plus 8 is 44. All right, we can use a calculator if we need to. You know, getting down toward the end of the year, brains are tired, you're more prone to making little mistakes, so don't be afraid to use that calculator if you need to. How many got the 44 for the answer? Okay, questions. Did we look up the formula?
I knew the formula. I just multiplied it by the first term.
So you put it in multiplication. Right, so a quick reminder, arithmetic adds and geometric multiplies. I think the homework this evening, no, that's the next lesson, is going to have some review of geometric. So that's coming. We're going to review those as well. All right, number 9. Go ahead and read the problem for us if you would, Kendall.
Lamar has 113 hits for his baseball season. He has 56 singles, 20 doubles, 1 triple, and 36 home runs. What is the probability that he will hit a double for his next hit?
All right, so we're finding relative frequency because we're basing this on past history. Now, this is when he does get a hit. This isn't the probability that he steps up to bat and he hits a double. It's what's the probability that the next hit he actually gets will be a double. How do I set up my ratio?
20 over 150.
Because successful for this means double. That's what we're asking about. So 20 times he successfully doubles out of 113 total hits. And we could leave it like that, though it did say round to 3 decimal places. Did you do that, or did you leave it?
I left it.
Yeah, we normally leave it. How many did do the 3 decimal places? What is it?
0.177.
Yeah, 0.177. I'm okay with the 20 to 113. I will usually ask for ratios, not decimals. But, I mean, just plug it in the calculator. By the way, I wouldn't plug it in as a fraction. That would take longer. I would just do 20 divided by 113 if I want the decimal. Have I showed you, by the way, how to fix the calculator to a certain number of decimal places yet? Let me teach you that real quick. On your calculators, go ahead and do 20 divided by 113, and you get 0.1769991 and blah, 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 right? Do you see right above your decimal key, it says the word fix. What this allows you to do is fix how many decimal places you want. So if you do second function, and then hit the decimal key, so you're going to fix, and then tap a 3. It'll fix your calculator to continually give you only 3 decimal places. It'll round for you, so you can't screw up the rounding. You don't even have to think about how to round. It'll do it for you. Now, the way to take the fix off, you either do second fix, fix, and that takes it off, or as soon as you turn your calculator off, the fix is gone. So the fix stays there until you change it, at least on this calculator. You guys, I'm sure it's there somewhere. Again, is it really that hard to round? Probably not. But, you know, hey, if you can be lazy, why not? Number 10. Go ahead and read that one for us, if you would. Abby.
Martina has a bag of beets. She has 20 purple, 6 pink, 11 blue, and 24 green beets. What is the probability that she will pull out a blue beet?
This is not relative frequency. This is just probability, by the way. Probability of a blue beet. How do we set it up?
11 over, after you add them up,
Good.
44, 50, 61.
There we go, 11 out of 61. So the first thing we want to do is figure out how many there are. Take the 11 blue out of 61. It doesn't reduce, we're done. Or if you got the decimal, which I think is what you did, you had
18%?
18% or 0.180 if they're doing the 3 decimal places. Yeah, 18% as a percent, which is what I prefer. Either that or the ratio. How many had? Either 18%, 11 to 61, or 0.180. Questions on that? Number 11. Read that one for us, Maddie.
Dora has a collection of small red cards. There's 12 blue, 15 red, and 8 yellow. What is probability that Dwight will randomly select a blue or yellow card?
Are these mutually exclusive or not, Maddie? Yes, they are. Blue, that which is blue is not yellow. So how many blue and yellow combined since it says or?
The 4, I updated over 4 or 7.
It reduces there, but how many, like, just looking at the problem, how many blue or yellow cars are there? Number 11?
12 blue and 8 yellow.
12 blue and 8 yellow, so total that's 20 cars, it says, right? Blue and yellow, add them together because it says or. That's 20 cars out of a total class of 35. And that's where Maddie got the 4 to 7. She did a lot of it in her head last night. I was just kind of looking at her answer there, 4 to 7. Again, if you went 3 decimal places, 0.571 or 57.1%. Number 12, read that for us if you would. Let's see. Brandon, you like hair bows. Why don't you read number 12? Get your wet brush.
Veronica has many different colors of hair bows. She has 4 pink, 6 yellow, 3 blue, and 1 purple hair bow. What is the probability that she will randomly select a yellow or purple hair bow?
All right, first thing we're going to do is figure out how many total. And Brandon, there were 14 hair bows. It wants probability of either yellow or purple. Are those mutually exclusive or not?
Yes.
Yes, they are. That which is purple is not yellow. So how many purple and yellow put together? 7. So 7 out of 14 becomes 1 to 2. 1 to 2 or 50% or 0.5. Or your likelihoods there on 12. Number 13. What?
I want to read this one.
You want to read Sierra's problem?
Yes.
Okay, read the Sierra problem.
Sierra has several objects on the floor of her room. She has 2 pairs of shoes, a shirt, 3 pens, a pencil, and a book, and 3 coffee cups, plus 4 cups from Starbucks.
Is this someone we know?
No, it's just every girl's problem having coffee cups.
Okay.
What is the probability that she will randomly pick up a pencil or a writing instrument?
0, because she's going to pick up the coffee cup that isn't empty. All right. All right, so with minuses modifications, how many items on the floor for Sierra?
A lot.
A lot, but if we just take the ones they mentioned,
8.
8. And it says pick up a pencil or a writing instrument. Are those mutually exclusive or not?
No.
No, definitely not. So really we just look for total writing instruments then. And how many total writing instruments?
4.
4. 3 pens and a pencil. So the probability is?
50%.
4 to 8, which is 50%, 1 to 2, 0.5, whatever. Questions on that? Number 14. I have to say, Leroy here in the picture looks like about the happiest guy in the world about having clean clothes. I don't know if his laundry machine broke and he's been wearing dirty clothes for a while, but I have to say, he looks thrilled to have a basket of clothes to fold. I personally hate folding laundry. We have finally taught our children how to start folding so we don't have to do it all. I say we as if I help very often. My wife is watching. She's screaming at the computer like now. She doesn't scream. She's sweet. But she's like, I do most of the folding here, pretty much all of it, except for the kids do. But anyway, Leroy is going to fold his own clothes, and he is stoked.
Finally old enough.
Mommy, let me do it. Anyway, read our Leroy problem for us, Audrey. We're having way too much fun at the pictures expense here. That face, though. Sorry, Leroy, or whoever the model is for this picture. Go ahead, Audrey.
Leroy has a basket full of clean clothes that he is put away. In the basket there are 5 dress shirts, 9 pairs of dress pants, and 3 pairs of jeans. What is the probability that he will grab either a pair of jeans or a pair of pants?
All right, are these mutually exclusive or not?
Yes.
Jeans or pants? No, because jeans are pants, right? So we first of all need to do, of course, is figure out the total number of garments that are in the basket. By the way, how many of you help fold laundry at your house? You're a responsible young person? Good, good. How many would wish the basket only had 17 items in it? Then you wouldn't be nearly as bothered by maybe that's why it's got a big smile. It's like, haha, it looks full, but there's only 17 things in here. I got it made. You know, she's got all the underwear in her basket. She's putting hers. I don't know how it works, but yeah, the socks are the worst. When you have 4 small children, socks are awful. Anyway.
Just give up on matching. These are the same size.
But then children have traumatic breakdowns, so we kind of have them do their own. But you find 2, roll them together inside out. We're good. Just toss it in there. Anyway, so 17 items total. How many total pairs of pants? 12, because you've got the 9 pairs of dress pants, 3 pairs of jeans. So what is the probability? 12 to 17, if you did percent, 70.6% or 0.706. How many have that answer? Questions on these? Did any of you laugh last night when you saw Leroy? You did? Okay. Yeah, I definitely, as I was going through this looking, I was like, that picture though, it cracked me up last night. All right, turn back to page 508, page 508. As we're turning, last questions on OR scenarios where we add the probabilities. All right, yesterday we looked at and again, class, when you see and, we need to multiply the probabilities together. In general, if the first outcome does not affect the second distinct outcome, the second choice, class, we would say the events are independent. And we just find the probability, we multiply, everything's happy, we have the calculator to help us. That's why it's happy. All right, if, however, the first event changes things, and we looked at this yesterday right at the end of the hour, we've got to be ready to account for it. Look, if you would, at the bottom of page 508, read the example 11.2c for us, if you would, Abby.
Suppose 12 candies are hidden in a bag, 7 red, 3 blue, and 2 yellow. What is the probability of selecting 2 consecutive blue candies without replacement?
All right, so, I don't know, nobody likes the yellow. How many of you like the yellow candies? Either the banana or the lemon or the pineapple or whatever. Yeah, a lot of people aren't fans of the yellow candies, but they like the blue candies here. And so how many candies total in the bag, class? 12. It tells us that at the outset, so we don't need to add them together. We can be lazy. What is the probability? You reach in the first time, hopefully they're wrapped, because otherwise now they're all mine. But I reach in the bag, and I pull out, and they all feel the same too. And I'm like, hey, it's a blue one. What's the odds, class?
21.
Well, there were 3 of them in there, right? So 3 to 12. But then it says without replacement, meaning, yes, I wanted blue. I unwrap it, pop it in my mouth. I'm like, wow, that's excellent. I shall have another. And so I reach down again, feel around in the bag, pull it out again. Now what's the odds that one's blue? There are not 12 candies anymore, are there? There are now only 11 in the bag. And of those, only 2 of them were blue now. Do we see how dependent events, we simply have to account for the fact that one's been taken out? And so we can do a little canceling here to get 1 and 6, and a little canceling here to get 1 and 2. In class, we get
1 to 22.
a 1 to 22 chance of that happening. So if I tried 22 sets of double draws, theoretically, based on this, after every 22 times, one of those times, I would get double blues on consecutive draws. Questions? Does that make sense? We remember that from yesterday looking at that. Look at the next page. And read example 11.2d for us, if thou wouldest, Michael.
Suppose 20 candies are hidden in a bag, 9 red, 3 blue, and 8 yellow. What is the probability of selecting a blue candy and then a red candy without replacement?
All right, so we got 20 in the bag. It says, what's the probability of blue, then red, but not replacing the blue? All right, so we eat the blue. What's the probability of blue, class?
3 to 20.
There are 3 blue in the bag out of 20 total, so 3 to 20. Pretty easy. If I don't replace the blue, I eat it. How many candies in the bag now, class?
19.
19. How many of them are red?
9.
All 9 still red, right? We didn't take any reds out yet, so we still have 9 reds, but it's now 9 out of 19. Again, we can do, no, we can't do any canceling. So I'm still just multiplying, class. 3 times 9, and 20 times 19, 380, and there we go. 27 to 380 chance. They found the decimal would be like a 7.1% chance of it happening. Again, the key words for dependent events without replacement. What if it said with replacement? What if I pull out a blue, I'm like, oh, I hate blue candy. I put it back in the bag, which means that there's a chance I draw it again. And I reach it, I pull it, yes, I wanted red anyway. Well, the only difference here, class, would be, instead of a 9 out of 19, it's 9 out of 20, because I still have all 20 candies I could draw from, which changes it down to 27 to 400. That make sense? So the with replacement, without replacement, we just got to be ready to account for it. There's a little table there at the bottom of page 509 showing the compound probabilities. Your ORs, mutually exclusive, just add. Not mutually exclusive, add, but then subtract that overlap at the end. With the and, we multiply. If they're independent, just multiply. If they're dependent, then the order of the draw is going to make a difference, and we're going to find the probability of B given A, or accounting for the fact that A has happened, which means we have to do a little bit more thought. Questions on that table? Turn over to page 510. Flip the page. Let's take a look at number 1. And read that for us if you would, Brandon.
John has a collection of pencils with 10 blue, 3 yellow, 1 green, and 6 red.
Alright, part A.
3 consecutive yellow pencils are chosen with replacement.
What are the odds 3 yellows in a row with replacement? Well, class, if I replace each pencil as I draw it, dependent or independent? Independent, because drawing the pencil the first time doesn't affect the next draw if I put it back. So these would be independent events. We're not going to take time to find them. We're going to do those in a minute. For now, just dependent or independent. Letter B, a blue pencil and then a red pencil are chosen without replacement, meaning I pull the blue, but I don't put it back. Then I draw red. Dependent or independent? Dependent now because I didn't replace the first. Easy enough? You're looking for those clang words in many instances, not all. I gave an example the other day, right? Where if I may not use the words, for instance, if I say, pulls out a pencil, breaks it, pulls out another pencil. Okay, but he's obviously not replacing it, even though I didn't say without replacement. Pulls out candy, eats it, and pulls out another one. Well, even though I didn't say without replacement, I've insinuated we're not replacing it. Does that make sense? But a lot of times they will use the actual words. Number 3, read that for us, Maddie.
Martha has a jar of folded paper notes with 4 colored red, 8 colored yellow, 10 colored green, and 2 colored blue. 1 green note, 1 red note, and 1 blue note are chosen as replacement.
Pull out, no, not this one, we put it back. Pull out another note, I like this one, that's nice. Put it back. What, would that be independent or dependent, class? Independent, because we're putting them back, which means we don't affect the next draw in any way. Letter B, consecutive yellow notes are chosen with replacement. Still independent because it says with replacement. So I pull out a yellow note, oh, I like yellow. And then we put it back. And we pull another one. It might even be the same yellow. But the odds are still the same as they were before, still independent. Does that make sense? Now let's go to number 5, and we're actually going to find the probability. Here, read number 5 for us, Kendall. Through part A.
Mark has a collection of 21 blue stones, 4 red stones, 7 yellow stones, and 9 purple stones. 2 consecutive yellow stones are chosen with replacement.
You wonder what he's doing with all the colored rocks. I don't know. Anyway, we don't ask questions. We just find it. All right, so how many stones total? That's always going to be your first question, class.
41.
41 total. So Kendall, remind me, you said he wants the probability of a
Yellow stones.
yellow stone, and then,
It's 2 consecutive.
oh, consecutive. So yellow and yellow is literally what it's asking for, right? All right. How many yellow are there, class? 7 out of 41. Do we replace or not replace? We do replace. So dependent or independent?
Independent.
Independent. So on the next draw, class, there's still how many yellows?
7.
Out of how many total?
41.
Still 41. And we just multiply. And obviously 7 times 7, 49. And 41 times 41, help me.
1681.
1681? Let's go with that. So there's a 49 to 1681 chance of yellow than another yellow. If we wanted to, we could divide that. We could get our percentage if we wanted to. I'm just going to leave it like that. Letter B, blue, then red with replacement. So probability of blue and red. What's just the probability of blue, Audrey? 21 to 41. What's just the probability of red with replacement, Brandon? 4 to 41. And class, since it says and, we're going to multiply. Can I do any canceling? No, 41 is a prime number, so it doesn't really let us cancel anything. And so I multiply, and what do I get for my odds this time, anyone?
84 to 1681.
Good, 84 to 1,681. And we didn't have to multiply 41 times 41 again, did we? Because we already knew it was 1681. Wasn't that nice? All right, letter C. Blue, then purple, chosen with replacement. I'm lazy, so I'm going to do this. How many purple were there, class? 9. And if there's replacement, then it's 9 out of 41. And so, what are the odds of blue, then purple?
189.
Out of
1681.
1,681. Questions on letter C. Letter D, what are we trying to find here? Kendall?
In blue, red, and yellow stone are chosen in that order.
Blue, then red. I'm going to do blue and red and yellow. In that order. All right, well, what's the probability of blue, class? 21 to 41, okay. Then it says and, so we're going to multiply. We did have replacement, it said. What's the probability of red then? 4 to 41 still. And, so we multiply again, yellow. 7 to 41. Now, in the denominator, we already know 41 and 41 is 1681, right? Multiply another 41 by that, what do we get? Or 41 cubed.
68,921.
Someone else got that number? 68, whatever she said? 68.
921.
921. All right, and then in the top, we got 21 times 4 times 7.
588.
588. And again, there's no canceling you can do anywhere, is there? So it doesn't reduce. We don't even need to try it, which is good because you can't type that in because it's too big. But there we go. Questions on those probabilities in number 5. Skip across the page to number 9. Number 9, and readeth this one, Brandon.
In this game has a deck of cards that contains one card for each number 0 to 9. A 4 and then a 0 shows without replacement.
All right, probability that a 4, then a 0, it says without replacement. Okay, that's important. That means, class, these are going to be dependent. All right, so you said the probability of a 4, then 0. So 4 and 0. But since there's no replacement, probability of a 4, class.
1 to 10.
That's one number out of 10 cards. Then the probability of 0. Well, how many zeros are there? 1 out of how many cards total?
9.
Now only 9. So what are the odds of a 4 and then a 0, class?
1 to 90.
1 to 90. It's making sense? All right, go on to part B. What are we looking for now, Abby?
3, then an 8 are chosen without replacement.
So the probability of a 3 and then an 8. What's the probability of a 3, class?
1 to 10.
1 to 10. If the 3's been chosen, what's the probability of the 8? 1 to 9. And since it says and, we're going to? And what do we get? 1 to 90 again, because we're still picking 2 different cards, right? A 7 then a 3 without replacement. Well, 7 and 3. What are my probabilities, class, for 7? 1 to 10, and we're going to multiply for 3. 1 to 9, so we're going to get 1 to 90 again, right? What about the probability of a 3 and then a 3 again without replacement? 1 to 10 for the 3, right? What's the odds of the next 3 if there's no replacement?
0.
0 to 9. So what are the odds you get a 3 and then another 3 without replacement? 0. That's impossible, right? You can't do that because there was only one 3 to begin with. Anyway, that just sounded more interesting than what they were doing. Letter D, a 1, a 2, and a 3. What's the probability of the 1, class? Probability of the 2. 1 to 9, since we didn't replace. Probability of the 3. 1 to 8, since we didn't replace. And so the probability is?
1 to 7.
1 in 720 chance that we draw 1, 2, 3 in that order. Questions on number 9. Number 11, let's do one more together and I'll have you work some of these on your own. Number 11, and we don't have any Heidi's in here. I don't know.
Abby liked the movie.
You like the movie?
I did.
I don't know. I think I watched it once. She's a little Swiss girl, isn't she?
Yeah.
Little Swiss girl. Something happens. I don't even remember the plot.
She goes to her grandfather's house with a goat or something. Yeah.
Doesn't she like save her grandpa?
Yeah.
So she's a hero. Okay, all right.
What?
So hero. Let's see who in here looks like a hero. Everybody looks away except Abby. Abby's like, right here, hero, and heroine.
If I keep reading this.
You will be if you keep reading it. Okay, so read number 11 for us, Abby.
Heidi's family has many different umbrellas. There are 4 small, 3 medium, and 2 large size umbrellas. 2 large umbrellas are chosen without replacement.
All right, so it's raining outside. Go to the umbrella rack, but it's dark in the house because of the fierce storm that's not going to come Friday, we're praying. And somebody reaches down, it's like, I got one. Hey, it's a large umbrella. And they walk out into the rain. Actually, they open the umbrella, and then they walk out the door, then they open the umbrella, and they go out into the rain. Next person comes along in the dark, and they say, I found an umbrella. Hey, it's also a large umbrella. Well, you could argue they found a large umbrella in the dark because it stands taller. But anyway, the odds of 2 large umbrellas chosen without replacement. How many umbrellas total, class? 9. Okay, so the probability of large and large without replacement. So the first guy takes the umbrella, doesn't come back, okay? What's the probability of the first large? 2 out of 9 were large. What's the probability of the next large if we don't replace? Only 1 large left out of 8 total. We can do a little canceling here. Do the canceling, save yourself the work, and then we get a 1 to 36 chance of large and large. Now again, that assumes no free will, right? How many of you would always rather have a large umbrella over the small umbrella? Okay, always good, keeps the rain off better, right? What's the point of the small umbrella? I don't know. What? Hit people with the small umbrella. All right. Small and then large, chosen without replacement. So probability of small and large. All right, probability of small umbrella, class. 4 to 9. They got lots of small umbrellas because nobody wants them, and so nobody loses them and breaks them. And then the probability of large umbrella if we don't replace the small. We've got 2 large, remember, but it's out of 8 total because the 1 small is already gone. We can cancel both the 4 and the 2 with the 8 to just leave ourselves with 1 to 9. Questions on that one? All right. Probably what happens, you pull a small, like, that thing doesn't open very, very big, you put it back and you grab the large. So probably there was replacement, but it says not. Medium, then small. So medium and small. What's the probability of medium, Michael?
1/3.
3 to 9. We could reduce it to a 1 to 3 if we wanted to early. There is an advantage in waiting to reduce until the end so you can track the progression. What's the probability of small, Michael?
4 to 8.
4 to 8, which is going to become
1/2.
1 to 2. And so the probability of grabbing a medium and then someone coming else along and grabbing a small is 1 to 6. And then at your seats, do letter D, a large and then 2 smalls. Probability of large and small and small. Maybe the small umbrellas are for little children. My kids have small umbrellas.
Or for the friends that you don't like.
Or no, that's true too. That's true too. Or if you're out with a girl, a young lady, and it starts to rain, and you want to help protect her from the rain, but you only have a small umbrella, so you've got to kind of squeeze close together if you're both going to stay dry. I mean, what options do you have? None. You know, we had to. I'm not actually advocating that.
It sounded like you're speaking from experience.
Well, anyway.
I am documenting this.
This was on YouTube. Whoops. All right, what's the probability of a large umbrella, class?
2 to 9.
2 to 9. You could always tell in college the guys who had girlfriends always had small umbrellas. The guys without girlfriends had large umbrellas. The guy with the large umbrella figured large umbrella, more girls can gather under it. I can help more women and increase my odds. Guy with small umbrella, I already got the one girl I want, and I just want her close to me, so small umbrella. See? Tell the guy the nature of a guy from his umbrella. Anyway. That and the single guy was always playing video games. Anyway, so the large umbrella, Brandon's like, oh, ouch. I don't even know if he plays video games. I just like picking on Brandon.
I did. He doesn't even have an umbrella.
He doesn't even have an umbrella.
I know. My mom does.
He's like, I find girls with umbrellas. I still remember, this was cracked me up. So the administrator at Pensacola Christian Academy, where this is produced, his name is Mr. Burks. And I remember one day I was standing outside of school, and the math teacher, Mrs. Howe, was walking up to the school carrying her umbrella. He had no umbrella. He comes sprinting up and gentlemanly offers to hold the umbrella for her. What a gentleman. I was like, way to go, Mr. Burks, helping her out. She should not have to carry her own umbrella. Brandon has no umbrella. He looks for girls with umbrellas that he can help and hold it for them.
Amen. So you don't graduate to being a man until you get your own umbrella.
Pretty much. All right. Anyway, we're having way too much fun with the umbrellas here. Large umbrella.
Brandon, I already got my own umbrella.
Oh my. Brandon's like, I got a raincoat.
I know.
You can't share the raincoat, Brandon. No, stop it. All right,
Brandon.
2 to 9 for the large umbrella. We're going to try to get through this. Small umbrella, class, once the large umbrella is taken.
4 to 8.
4 to 8. Another small umbrella once that one's gone.
3 to 7.
3 to 7. And of course the 2 and the 4 can cancel with the 8 completely, and then the 3 and the 9 cancel to get
1 to 3.
1 and 3. So the odds of large, then small,
1 to 21.
1 to 21. Did we have that before we got distracted? All right, rabbit trails, bunny paths, whatever. All right, do numbers 2 and 4 on the previous page. 2 and 4, dependent or independent, but D or I, because we're lazy. It's a long word to write. Though, you do want to make sure you know how to spell it for quizzes and tests. Y'all know how to spell it, right? You can do D and I and not screw it up later. Yeah. Michael, write the whole word. Or on the test, you find somewhere where it shows up, and now we know how to spell it. Okay, that's where it is. Yeah, I've done that before when grading tests. A student misspells a word. I'm like, if you look down here 2 questions later, you see that word right there. There's no reason to misspell it. It's just have to look for it a little. Testing strategy. See all kinds of tips.
Yeah.
How to help a girl with an umbrella, and how to take a test and spell things right. 4A. 4 consecutive spoons chosen without replacement. Class? Dependent. Thank you, Abby. Class, letter B. Fork, steak knife, butter knife chosen with replacement. Independent. Number 4. 2 baskets, pairs of shoes. Tennis shoes, then sandals, then dress shoes without replacement. Dependent. Find somebody wearing 3 pairs of shoes. Letter B. Sandals, 2 pairs of dress shoes without replacement. Again, dependent. Questions on dependent, independent. All right. Do number 6. All 4 parts. Do number 6. All 4 parts. Oh my. That last one's awful.
Mm-hmm.
Three quarters. Lost and found. 3 umbrellas. I guess
Are there umbrellas in most of the time? Brandon might need one.
I don't know.
I don't need it.
We know that. But
Or you just catch pneumonia. There's that too. I mean,
I gotta catch that.
get out of school for a while.
Exactly.
Get sympathy cards.
Mm-hmm.
You can get one from a girl. I mean, see? Maybe no umbrella's a strategy that works. I had one kid in junior high. I still remember his words of wisdom. It's like, yeah, I know it hurt when I broke my leg, but the cool thing is, like this girl I wanted to pay attention to me, she never paid any attention to me. Now she feels sorry for me. She talks to me and stuff now. So I think this crutch thing is working out. Words of wisdom from junior high boy.
Oh, yeah.
Brandon's like, oh, that's what I gotta do.
break your leg.
All right, for sake of time, let's take a look at these. All of these say with replacement. So class, the denominator every time is going to be 65. Now, we could do some reducing in there, of course, occasionally, not very often, but every time it's going to start as a 65 until we reduce. So, 2 consecutive quarters chosen with replacement, Kendall?
324 over 4,225.
Good, 324 out of 4,225 chance. How about penny then dime? Michael?
300 over 3,025, which I did not reduce.
Not 3,025, that's odd. I had 300 over 4,225, which could reduce, but I reduced the 15 and 65 and the 20 and the 65. What did you have, Maddie?
12 over 169.
That's what I had as well. I had the 12 to 169. I divided the 5s out of the top and the 5s out of the bottom to get 12 to 169. How about nickel then dime? Let's go back to Michael for redemption.
They're all going to be wrong because I did 55.
Oh, okay, so just an addition error. All right, well, now we know. How about letter C, Brandon?
48 to 845.
Good, when you reduce 48 to 845. Good job, Brandon. Awesome. All right, letter D, 3 quarters, then a penny chosen with replacement. The odds are very, very small, about 0.5%. But what's the ratio? Audrey?
1,132 over 17,850,625.
Oh, that's not what I got. What did you got, Abby? Aubrey, whatever your name is. Audrey, Abby.
87,480 over 17,850,625. Or,
Did you reduce?
no.
Okay, I knocked out the 5. I did 18 to 65, 18 to 65, 18 to 65, 15 to 65 on the penny, but I reduced the 15 and 65. Kendall?
Yeah, I did that.
Didn't do that. Anyone else? Anyone do that? Okay, because that's the only way you're going to be able to reduce too. But try dividing a 5 out of the top and a 5 out of the bottom. Divide them separately.
You get 17,496 to 510,125.
I think that's a 570,000. I think that's a 7. I got 17,004, unless I'm misreading mine, that's possible. 17,496 out of 3,570,125. Do we have that now? All right, getting a nod from Maddie. Questions on those? All right, number 12 across the page. This time they're without replacement. So dependent events we're looking at. These numbers should be a little bit easier. A little bit easier. Yeah, just barely easier. How many stamps? 48. So we'll start with the correct total. Always important. Right, Michael?
Mm-hmm.
Michael, what'd you get for the first one?
6 over 2,256.
It is, but you can divide a 6 out of both of them. Someone have a reduced answer for number 1? Yes.
1 to 376.
1 to 376 chance. On the next one, really, I didn't reduce mine either initially. For the next one, I have a reduced answer of, go ahead.
5 to 752.
Good. Initially 15 to 2,256, but you can divide a 3 out of both to get 5 to 752. On letter C, this one actually isn't too bad. We end up with,
5 to 235.
I got 5 to 94. No, let's get 5 to 94. Maddie got 5 to 94. Initially, we'd have 120 to 2,256. And the last one's a fun one, letter D. I'm going to give you the answer and you can check and see if you get this answer. 10 out of 1,081. 10 to 1,081 is what I got for that. 2 chances at extra credit for you this evening. 2 chances at extra credit, but each answer I'll need all 4 parts to be right to get the extra credit. So it's kind of 8 problems disguised as 2. Page 510 to 511, numbers 8 and 10. So number 8 and number 10 we had skipped. Those are extra credit. We'll look at them first thing tomorrow anyway. If you happen to already have them done correctly, you get some extra credit on your next test coming up next week in about 3 or 4 lessons. I'll have more information once I have an actual date set. All right, have a wonderful rest of your day. Pages 510 to 511, numbers 8 and 10, the extra credit. Have a great day.